All right, guys. Sorry I'm not there today. I'm not feeling great. I was diagnosed with pneumonia, so I'm at home trying to get better. But in the meantime, I wanted to make sure that I went through this lesson with you so that you understood everything that you needed to. So I do want to let you know that the calendar has a lot of information on it. It is a new packet. It's your last packet. Yay. So we will go over that when I get back. For now, just kind of do the usual, do your homework. It's in your packet still. And then again, we'll go over finals and testing and all that good stuff after. So anyways, if you turn to the first page, it says conics. The shape that you see on the page should look familiar from geometry. You'll see the McDonald's logo, all the good stuff. So today we're gonna graph parabolas. We've done it many times before. This time is a little bit different because we're gonna graph the focal distance, which we'll go over that today. So these are actually very easy. So once you kind of pick up on it, it works. So anyways, all right. So on the first page, you have this like fill in the blank section, right? And sorry, that was our dryer. So you have this fill in the blank section. I'm gonna go ahead and fill it in with you, and then we'll kind of go from there. Okay, so a parabola is defined as the set of points. So a parabola is defined as a set of points such that the distance to a fixed point, so this is important, a fixed point, it doesn't move, called the focus, is the same as the distance to a fixed line, a line that does not move, called the directrix. Okay, so the focus and the directrix are the two pieces of information that you are going to have on every single graph. You cannot use 149 to graph these parabolas, by the way, but I will show you another way to get around it. So below that, you have this graphic with 3 boxes. I think these are in the right order. If not, just switch them. So the focus is that top point. The vertex, as you know, is the starting point of your parabola. And then the directrix is that dotted line, kind of where the parabola is sitting, okay? So go ahead and fill those in, and then go ahead and flip the page. On the next page, you'll see this little table, this graphic organizer. It's got 2 separate equations on it. The difference between these 2 equations is simply the x and y are switched. Okay, that's the only difference. There is a specific time where you have to use certain formulas, but we'll get into that in a minute. For now, I just want you to understand which way these graphs will open. Okay, so this is our vertical row, and this is our horizontal row, which I think is already on your paper. So I obviously don't have your notes with me, so I had to like make these up. So I'm trying to do them as accurately as possible. Anyways, okay. So the whole thing that drives this problem is the last letter. That last letter tells you a lot. It's going to tell you the axis that you're going to graph off of. So since y is last, I'm going to be using the y-axis here. So either my graph is going to open up if it's positive or down if it's negative. Well, how do you know it's positive or negative? You look at the p-value, which is in that formula, and we'll talk about how to get that in a second. But for now, let's make up a p-value. So what is a p greater than 0? So think of any number. I'll do 3. So positive 3 is greater than 0, right? So if I graph that, positive 3, your parabola is going to hug that point. Again, it's called a focus. So if you think about your parabola is going to focus or look at that point. Now the directrix is the opposite of this. So if the focus is up 3, the directrix is going to be down 3. Okay? So let's jump ship over here, keeping in the vertical row. Again, the last letter is y. So that means I'm still going to graph along this y-axis. But in this case, p is going to be less than 0. So let's think of a number less than 0. So if we think of -2, that's down here, right? And again, your parabola is going to focus on that point or hug that point. And the directrix is just going to move in the opposite direction. So if the focus is down 2, the directrix is going to be up 2. So there's not much thought that goes into those. So if we do the bottom, so now the last letter is X. So this is going to change things up a bit. This is referring to the X-axis. So either my parabola is going to, sorry, open right or left. So again, if you think about P being greater than 0, what is a P greater than 0? Let's go ahead and use 3 again. 3 on the X-axis is over here. And then, of course, you want your parabola to hug that, which means the directrix, again, is just the opposite. So if I moved 3 to the right, I'm going to move 3 to the left and draw that directrix. You could probably guess that last one. So go ahead and start this. So again, X is my last letter, so I'm going to be on that X-axis. But what is a number less than 0? Again, if we do -2, that's over here. And again, you want your graph hugging or focusing on that point. Your directrix is opposite that on the other side. So really, it's all about your p-value, right? So go ahead and flip the page. Let's figure out how to specifically find this p-value. So I want you to keep this page kind of close because we're going to be using these two formulas, okay? So the first example here, x squared equals -8y. I hope I didn't change the problem. Anyway, so we've got a couple questions that we'll answer over here in just a second. But for now, I just want to focus on this problem. So here's what you do. You look at your problem, and then you look back at the formulas. And you ask yourself, which formula is almost identical to my problem? And it's really easy. All you do is go, well, my problem has x squared, so I'm going to steal the x squared formula. And what I want you to do is I want you to take this and write it underneath. So x squared equals 4py, okay? And then you're going to cross out all your twins. So I have x squareds that are twins, I have y's that are twins, and I have an equal sign, right? And so that leaves me with -8 and 4p. So imagine having an equal sign in here. I want them to equal each other. Or an easier way to think about it is 4 times what number equals -8? Some of you are probably thinking -2, right? And the way you get that is you set it up. 8 equals, or -8, right? And then you solve for p, so I'm going to divide both sides by 4. So -2 equals p. Well, what in the world do I do with that p value? Again, the p is determined by that last letter. And what was our last letter? Y. So that refers to us moving along the y-axis. So I'm going to go to -2 on the y-axis. And so that's down here. Sorry for my sideways graph. The directrix is opposite that, right? So if I went down 2 for my focus, I can go up 2 for my directrix. And then what's my midpoint? My midpoint is this vertex, 0, 0. So how do you find your other point? It's really easy, actually. If you go back to the original number, -8, and you split it in half. So what's half of -8? You're probably going to say -4, but honestly, the negative doesn't matter. So just think of the number 4. You're going to go down to your focus, and you're going to move 4 places to the right and to the left. And this is going to give you your points. So again, I'm hugging that focus. I'm using the focus to get my other points, but I don't want to draw my graph through the focus, right? We're hugging it. Okay, so let's answer some questions. Did it open left, right, up, or down? Obviously, this is down. Where's the focus located? Again, that's the fixed point, and it's located at 0, -2. Where's the directrix? It's located on the y-axis at +2. And then that's it. I'm done. So let's try the next one. So what's so different about example number 2? Obviously, that both variables are on the same side. So how can we fix that? By simply moving 16x, right? So if I subtract 16x from both sides, now these forms look the same. So again, go back to your original formulas and pick the one that looks the most similar. So x squared or y squared, which one looks more similar? Okay, so y squared, obviously it looks more similar to this, so y squared equals 4px. Again, get rid of your twins. And then whatever you're left with, set them equal to each other. Again, some of us I know can do it in our head. 4 times what is negative 16? But the way you would set that up is 4p equals negative 16. Divide both sides by 4. So p equals negative 4. And then again, what do you do with that negative 4? You refer back to that last variable. And that last variable was x. So I'm going to move along the x-axis at negative 4. So that's the focus. Where's the directrix? It's just the opposite direction. So I can go positive 4. Can you tell which way your graph's going to open up now? So it obviously hugs the focus, right? So it's going to open left. So I can kind of already see that. Okay, so where's the vertex located? It's your midpoint. It's always at 0, 0, by the way. That's never going to change. And then how do you get your other point? Again, it's really easy. You go back to the original number. So here was our original problem. Well, kind of original. And you refer to the whole number, negative 16. Cut that number in half. Half of 16 is 8. So you go to your focus and you move 8 in both directions. So 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And again, the reason we do half is because if you add this 8 with this 8, that's how you get your 16, right? And then why is it negative? Well, because it's pointing in the negative direction. So that's why it's negative 16. Okay, so again, let's get our information going. So the focus is that fixed point. That fixed point is located at negative 4, 0. And the directrix is located on the x-axis at positive 4, right? Okay, so again, we are done. So what I would like you to do is I would like you to try example 3. I want to give you like a couple minutes, and then I'll do like a part 2 of the video so that you can watch me walk through this, and then we'll wrap up the notes. We have 3 more examples, okay? So again, I'm just going to stop this. Go ahead and try it on your own.